First, we'll analyze what the first derivative test tries to tell us, and it will tell us either a maximum point or a minimum point. In order to get the first derivative test, we have to obviously get the first derivative, and we will label this as f prime x, and the result we'll label it as a. After this, when we have the result, we will put f prime a plus 1, and that will be equal to b, and also f prime a minus 1, and that will be equal to c. Okay, and from these results, if b is positive and c is negative, this means that the function has a max point, and if they're the other way around, it means that there is a minimum point. The second derivative test is a bit easier, because as we already have a, we will put already f prime of x equals a. We only substitute this a into f double prime. We have to get f double prime a, and that will be a number. That will give us a number. If the number is greater than 0, it means that it's a minimum point. If number is equal to 0, it means it's a point of inflection. And if x is less than 0, it means that it's a maximum point. Now we move on to the other part of calculus, which is integrals. It's important to state primarily the relationship or the differences between definite and indefinite integrals. And indefinite integrals means it's already an antiderivative, but on the contrary of the definite integral, it does not have any upper or lower limits, so it will always, in the end, the integral will have a plus c, while a definite integral is just an integral with start and end values, and from the definite integral we can calculate the area under a curve or the volume. Here, and we already defined what indefinite integrals were, so we will put the standard integral rule present so you can have a better understanding of what it is. The rule states that the integral of xn dx will be equal to xn plus 1. Here we see the x plus 1 and the contrary of the derivative, where it's x minus 1, and we divide this by x plus 1. And if, as here we have the example of being indefinite, the answer will always have a plus c. A quick example of this would be the integral of minus 24x x to the 5th power dx, and this would be equal, as we already put minus 24x x and 5 plus 1 6 divided by 6. Our answer would be 4x 6 plus c. As we considered previously that integration is the antiderivative of a function, we can see that the rules of primitive functions are the opposite of what the derivatives state. For example, when we have fx equals cos x, the integral of cos is equal to sine x plus c. When the integral is sine x, when the function is sine x, the integral is minus cosine of x plus c. We have to always remember to put c. Now, when it's the function e to the x, the integral, don't forget to put dx at the end of each function, the e to the x remains the same. Here, a method for integrating is u substitution. U substitution looks for a term within an integration that can be substituted by u. An example for this is the integration of e 5x plus 2 dx. First, we have to substitute a part of the function for u. In this case, it would be 5x plus 2. U equals 5x plus 2. The du dx is equal to 5. And then we substitute it back into the equation, where the 5 will be 5 dx, so it would be 1/5, and it goes to the principal, the first part of the equation, so it would be 1/5 e u du, and then we can substitute completely into the final equation, which will be 1/5 e 5x plus 2, we replace, plus c. Finally, I will speak about the application calculus has to certain other topics. In this case, it would be physics into the topic of kinematics. The three important parts of kinematics are displacement, velocity, and acceleration. In order to obtain these, we use calculus by means, for example, if we have the displacement and want to find the velocity, we will go down we will find it by means of finding the derivative. And in that sense, if we have velocity but we want to find acceleration, we will do the same, and it will be the derivative. On the other hand, if we have a lower term and we want to find the upper term, in this case acceleration to velocity, we will find the integral of x, and in the same sense, velocity to displacement is the integral of x. Thank you for watching, and I appreciate your attention.